Production of hydrogen from sawdust. Hydro- Hydrogen and its uses. Hydrogen is the lightest and most abundant element in the universe. It emits water vapor when combusted, reducing carbon emissions to the atmosphere. It's used in hardening of oils to produce margarine and also used as fuels in rockets, spaceships, and even cars. It is also used in ammonia and methanol synthesis. Overview of the chemical processes. We have the pretreatment of sawdust, sizing, gasification, syngas conditioning and cleanup, hydrogen purification, including the use of the water gas shift reactor, storage and distribution. Chemical process plants. So this is the overview of the chemical process plants. This is what we generated with the Microsoft Visual. Sawdust pretreatment and sizing. The sawdust has moisture content which needs to be removed before going through the gasification process. This involves the use of a dryer. After drying, it is sized down to much smaller sizes and to increase the surface area for reaction in the gasification reactor. A rolling grinder was used for this part of the process. The sawdust is reacted at high temperature with catalyst, steam and then air. This converts the sawdust into synthesis gas, which is known as the syngas. The syngas contains various gases such as the carbon monoxide, carbon dioxide, hydrogen gas, and methane. Syngas conditioning. The syngas from gasification contains impurities that needs to be removed for high purity hydrogen production. Tar formation was handled by catalytic reforming, which converted it into more pure and efficient syngas. Hydrogen purification. A pressure swing adsorption was employed in this process since it's a multi-bed system which operates in cyclic manner and operates in a way to selectively adsorb onto materials and varying pressures. It uses adsorbent materials and these materials selectively adsorb impurities at high pressures and release them at low pressures, yielding high purity hydrogen gas up to 99.9%. Storage and distribution. The purified hydrogen gas is then compressed to high pressures and stored in high-strength gas tanks. It may also be converted to liquid hydrogen by storing them under cryogenic conditions in vacuum-insulated tanks to minimize boiling. Hydrogen sensors are used to check for leakage and also prevent accumulations of the gas on the site. The site layout of all units including the main chemical process plant. Administration building, which entails the offices of management, finance, HR and planning teams. We have the control room. Given the highly flammable nature of hydrogen, it's essential for a control room to be provided to house all the process control systems within and outside the plant. We have a warehouse which serves as a storage space for all equipment and also storage of the hydrogen after production before management and selling. Hydro we have the laboratory for quality control, gas composition analysis and R&D positioned near the production area for quick sampling. We have the security room which has CCTV cameras at the main gate with surveillance system and access control through the use of barcode scanners and keycard access. And instruments integration.
So these are some of the images of the instruments and then the sensors used within the chemical process plant and then around the site itself. The computer needs of the company as such that we have input devices such as sensors. These sensors detect and then send accurate and then real-time data to the control room. The kind of parameters they measure as some examples are temperature, pressure, and then the flow rate. And then they have their respective sensors associated with them. Moisture and humidity sensors. Since sawdust moisture since sawdust moisture con ten t can affect the efficiency of the thermal decomposition, moisture sensors are used in at the pre-processing stage to determine whether the sawdust needs drying. So before it goes through the dryer, we need sensors to detect all this moisture. And then we have gas sensors to help detect whether leakages are within the plant or around the site. And then we have facial recognition and then biometric scanners for security purposes, for entry within restricted zones and then free zones within the site or within the plant itself. Barcode and RFID scanners. These are used to keep track of all the parts and materials, raw materials within the plant. And then we have CCTV cameras for monitoring around the company site for any suspicious activity. So we have devices such as human machine interfaces and screens. So the large industrial grade monitors and then touchscreen interfaces are used throughout the plant for visualizing the processes in real time. So these output devices and screens will display all the parameters, the essential parameters from the sensors, and then this helps the control room detect and then know how to maximize the use of all the current devices within the plant itself. And then we have the supervisory control and data acquisition system, or the ADA system, which is used to display charts and then logs, which helps the operators to make decisions quickly and then efficient. Also have alarms and then warning lights. So these alarms are such that they help indicate whether there are anomalies or unsafe conditions around the site. Example, if there is leakages around the site, these alarms, after the gas sensor senses this alarm, it senses these um, dangers, the alarm triggers and then which sends out a loud siren which reports tells all the personnel around the plant to evacuate the building around the plant. And we have printers and then report generators which are used to generate lab reports, which are used to generate maintenance log to check on permission. Then we have specification for the computer system such as the servers within the system, because we run them on a network topology connecting on. These things need to have high performance rates. Hence, we use Intel chips, we use 256, that's high data RAM, and then we use a large amount of storage space using SSD, because SSDs are fastest at accessing data. And then we use switches from Cisco IE 5000 and then Siemens. Software we use for this plant is supervisory control and then data acquisition software. So this is one of the most critical softwares in the plant because they allow operators to monitor and then control industrial processes in real time. So they collect data from sensors such as the pressure, temperature, and flow meters, and then display it visually through dashboards or control panels. So this helps maintain safety and then process consistency within the plant and then ensure that operations stay within the safe and efficient limits. Then we have DCS, which is distributed control system, because it can allow for more detailed and localized control over complex processes, which can improve efficiency and reduce energy use. It is sometimes used in relation or in connection with the SCADA. Then we have security and access control, which are used to manage all the employee access to restricted areas of the plant using biometrics or keycard systems. Given the flammable and high-risk nature of the hydrogen, trained personnel should be allowed to manage these systems and then softwares. So there's also environmental monitoring and reporting software. So this environmental monitoring monitor the area and then the vicinity around the plant such that we maintain and ensure that we are not emitting dangerous chemicals or dangerous gases to the atmosphere, but we purify them before sending them out to make sure that we keep the standards of the environmental community. There are software that can also be used in simulation and modeling software such as Aspen, which helps to test ideas visually and avoid costly trial and error on the plant floor. So of network that was used is local area network, which is also called industrial Ethernet. So this is faster because it is actually wired using Cat6 cables or fiber optics. And then we have virtual private networks, which are used by managers to make sure that there's encrypted access to plant systems without risking. We also used Internet of Things to upload all the necessary information to the cloud and then real-time information to make sure that we have access and then use it to improve the efficiency of the chemical plant. Then we have the network topology, of which we use that topology in connection with the ring topology to make sure that even if one of the fiber link breaks, it doesn't affect every plant or every unit within the plant, but the data still continually flows and then it's consistent. Thank you.